Let me introduce myself. I used to work at Google, then ran my startup FutureCamp, then worked as a CTO of a startup for a while. I now work as a consulting CTO with multiple startups. Today we are going to talk about instantiation. How do we create and initialize objects? Initializers should set up the object fully. The client of the class that is using the given class, should not have to do any work afterwards. Right? Classes should be self-contained and self-managed. They need to take care of themselves. You shouldn't have to take care of them. They shouldn't be like babies. They should be like adults. Let's look at an example of an initializer. Swift calls them initializer. Other languages call them constructors. I use the language interchangeably. You can see they verify that, so this verifies that it's being called in the main queue or the main thread. Then it assigns member variables. Then it switches to the telephoto camera rather than the wide angle camera of the phone, right? And FutureCam is a photography app. It's a camera app specifically. It lets you take photos in the app, right? You don't take a photo and then import it into FutureCam to edit it. It's not an editing app, it's a photography app. And frame producer's job is to produce a sequence of images. And it switches to the telephoto camera if it is better. It ensures that only one camera is active. If necessary, it plays a shutter sound. It resets statistics so that, as the statistics are computed, they are accurate. The earlier data doesn't persist. It locks focus. It adds an anti-shake delay and it starts recording. So you can see it does a lot of work. This is how initializers should be. They need to do whatever is needed. In this case, the frame producer, as I said, produces a sequence of frames, and that is what the initializer should do. It should get the object into a state where it's ready to fulfill its contract. Some people object to doing work in constructors saying it's not testable. That is true and it is a consideration, but don't take it too far. Don't say you should never do work in constructors. Firstly, are you unit testing? Secondly, are you unit testing this class? If so, you can always refactor it. But as a practice, don't say we should never do work in constructors because that puts the burden of initializing the object onto the user of the class, which is not where it should be. And they may forget, they may initialize it the wrong way, they may accidentally call the initializer multiple times, they may call it after they use the object. All these problems come up. Initializers exist for a reason. Use them. Initializers should also create other objects that are needed. Let's look at the camera class, line 101. In this case, it initializes a mode, like a time-lapse mode or a photo mode or a video mode. All the modes that are there, each of them is represented by a mode class. Initializers should also make connections between objects. Here, for example, the AV asset writer, it's a class that creates a video file on disk. It writes a video file. It needs an input, which is a collaborator. And the input needs to be added to the writer. And that is what this initializer does. So initializer should make connections between objects as needed. Initializer should also check preconditions. For example, the orientation of the device should be known. It can be portrait or landscape or anything, but it shouldn't be unknown. So preconditions, what are the conditions that need to hold before this code can work? Like any function, you should first check preconditions. Otherwise, some of this code here goes bad, the highlighted code. Initializers should also check post conditions. After doing all this work, you got a success code. So preconditions are like, am I beginning with the correct state? Post conditions are, am I ending with the correct state? So that the next code that works in a predictable manner. If you have multiple initializers with common code between them, de-dupe them. In this case, I created a private helper function called continue init that both the initializers call. In some languages like Java, this is not needed. One constructor can call another. If an initializer can call a function that does the work that is needed, do so. For example, the mode class initializer calls camera changed. Camera changed, yeah, takes care of switching between the wide angle and the telephoto and any other camera that you might have. We could have repeated the code here, but DRY. Don't repeat yourself. So if you have common code between two initializers, factor it out. Or if you have only one initializer in a class, but some of the code that would have been there is already there in a helper function, call it. In this case, this function can both initialize the camera and change cameras. Moving on. Sometimes we can use a static factory function. Like make, which returns an instance. In this case, the reason we are using this rather than a constructor is that the object is deserialized by calling this function. So it has to return. You can't have a traditional initializer. The reason we call this a static factory function is there isn't a separate class. If you have a separate class called preview view factory, that would be a factory. This is a static factory. It's just a function in the same class. Initializers, like all functions, have to handle all cases. In this class 4-inch window, you have an initializer that needs to do something special to handle landscape orientation. Again, your code should work in all cases. Initializers should make decisions on behalf of clients. For example, this convenience initializer for asset writer input chooses a bit rate for the video of 50 Mbps. This is not a parameter because it puts the work onto the caller. And since we don't have different callers that need different bit rates, it's inlined here, which is perfectly fine. Not everything needs to be configurable. That has an overhead in itself. You can also have convenience initializers. Here, for example, when you create an affine transform, you can apply a transformation on the x-axis and the y-axis also. But we have a convenience initializer that has the same scale, which it applies to both. And this is typically what you do. If you apply different transformations, things will get stretched, which you don't want. Or skewed, whatever you call it. You can also work around limitations in underlying APIs. For example, in this initializer, you are creating a UI image from a CI image. So let's say this is a CI image object. Now you can say iOS already provides this initializer called CI image. But this takes an optimized path. It doesn't work in all cases. And for us, it doesn't work. And it was unclear until you understood the implementation, which itself means that this initializer is poorly documented, as is a lot of Apple stuff. So I defined a new initializer called CI image safely. So now you can invoke it this way. And this is unoptimized, but it works in all cases. So an initializer can work around limitations in the underlying API. Some classes shouldn't be instantiated at all. If you look at hint manager, it's just a collection of static functions. Now maybe this shouldn't be a class. That's a different point. I'm using a class just as a namespace so that I can call hint manager dot show long press for burst mode hint. If I didn't have this class, all these would be global functions, and I didn't want to pollute the global namespace. Anyway, that's a different point. But since this class should not be initialized or instantiated rather, the initializer is private for compile time safety, and in case it is invoked within the class itself, it throws an exception for runtime safety. So this is what you should do if an initializer is not meant to be called. Singletons should have private initializers like this IAP service. It's private. And the only instance is here. The difference between this and the previous cases, this doesn't throw an exception because you do want it to work. You just don't want other people creating objects. So anyway, this is a tour of how you can use initializers in different ways and what are some good practices to use them effectively. If you'd like me to work with your team on improving the code quality, there's a link in the description.